Yeah, in the last session, we discussed about SDLC, Software Development Lifecycle, right? Yeah, so we have completed 4 sessions, DevOps, DevSecOps introduction, and cloud introduction, technical questions and general questions, right? And also SDLC, Software Development Lifecycle, right? So today, we are going to discuss about servers, networks, basics, okay? So today onwards, regular sessions. Okay. So before going to the cloud, before going to start the cloud, first we need to understand the basics of servers and networks. The terminology is very, very important. So terminology is very, very important, right? Yeah. So what is server? What is network? What is a switch? What is a router? What is a load balancer? These are all very, very important. So before going to the cloud, before going to start the cloud, first we need to understand the servers, networks, basics. Fine. Yeah, let's get started. Yeah, so today's agenda here is look at here, everyone. Look at my screen. What is server? Types of servers, server client model, best practices, server architecture. What is operating system? Types of operating systems. What is network? Types of networks. What is IP address? What is subnet? What is gateway? Router, firewall, failover, load balancer. So these are all very, very important. Okay. Yeah. Now let's move on. What is server? So server అంటే ఏంటండి? Anyone having idea? What is server? What is server? Server is a computer. Server is a computer, right? So server is having high computing power. So servers are having more like multiple CPUs, multiple RAM modules, multiple storages, right? Servers are having high computing power, multiple devices available in the server, right? So look at here. A server is a computer that serves information to other computers called clients, right? So can connect to a server through either a local area network or wide area network such as the internet, right? Server is a computer that serves information to other computers like laptops, desktops, which are, we can say, client missions. So can connect to a server through either local area network or wide area network such as the internet, right? Fine. Now look at here. So types of servers. What are the types available in the market, in the data centers? Okay. Now look at here. 3 types of servers are available. First one is blade server. What is blade server? So a blade server is a modular server that allows multiple servers to be hosted in a smaller area. So these are the blade servers only. Look at here. So blade servers are often seen in large data centers, very thin servers. Thin servers. Blade servers are thin servers, right? So these servers you can see in large data centers, enterprise level data centers, right? So these servers are physically thin and typically only have CPUs, memory, integrated network controllers, and sometimes storage drives inbuilt. Blade servers are often seen in large data centers, enterprise level data centers. You can see this blade servers. Next one here is rack servers. Rack servers. A rack server is a server mounted inside of a rack. A rack server is a server so mounted inside of a rack. Rack servers are typically general purpose servers. Rack servers are typically general purpose servers that supports a broad range of applications and computing power. That supports a broad range of applications. So any applications you can deploy, right? Yeah. So this is the rack server. So in this racks, we can insert the servers and we can connect network power, right? We can install operating system. Finally, we can move to the production, right? Next one, look at here. Tower servers. Tower servers. A tower server is a computer that is built in upright cabinet that stands alone and that is designed to function as a server, right? Yeah, tower server. Tower server is a standalone server. These are the tower servers. These are all bit older servers, right? So currently we are using blade servers, rack servers. Fine. Next one, look at here. Client server model. What is client server model? Look at here. So these are the clients. These are the clients, desktops, laptops you can use as a client. And this is the server, right? So when the client requests to the server, immediately server give the response, right? When the client requests to the server, server give the response, right? This is the client server model. So we can use any desktop or laptop or any tabs also we can use to connect our servers through either internet or intranet or other networks, Wi-Fi, broad range of networks, any networks you can use. Okay. So most of the companies currently they're using Wi-Fi. So everywhere within the campus, within the office premises, they're using Wi-Fi, right? So by using Wi-Fi, so we can connect the servers from within the organization, within the range, we can connect, right? So normally every organization, every project team, they're using Wi-Fi everywhere in the office premises. Okay. Even though when we go to the breakout area, we can carry the laptop. Right? Next one, look at here. Server architecture. This is very, very important. Server architecture is a foundation layout or a model of a server. So based on which server is created and are deployed, it defines how server is designed. Okay. Yeah. So this is the server architecture. So before going to discuss about this, let me explain something like yeah. Now let's try to understand server architecture. Yeah, we can say initial phase of implementation. Initial phase of implementation. So this is, we can say, first phase of implementation. First phase of, so initial phase of implementation, or we can say first phase of implementation, right? So in this first phase of implementation, yeah, normally, for example, we have four applications. We have four applications like Java, Tomcat, Java, Tomcat, Python, and also, for example, Ruby. So we have four applications, right? Yeah. So these four applications, yeah, in the initial phase of implementation, initial phase of implementation, first phase of implementation, in 1990s and early 2000, in 1990s and early 2000, how the servers, how the project teams used to design the server architecture. So if they want to implement these four applications, okay. So for example, four applications we have: Java, Tomcat, Python, Ruby. So in 1990s and early 2000, project teams, they used to design like, for example, look at here everyone. For each application, they used to configure one server. One server, one application only. They used to configure in 1990s and early 2000. One server, one application, right? So 1990s and early 2000, highest capacity of the storage, highest capacity of the storage is 1 GB. In 1990s, highest capacity of the storage is 1 GB. 1 GB storages we used to use. 1 GB storages we used to use. Highest capacity of the storage. 1 GB. Right? So these are all 1 GB servers, 1 GB storage servers, right? For example, we deployed Java in the server. Java may occupy 300 MB. For example, Java occupied 300 MB. So remaining 700 MB space will be wasted, right? So 300 MB occupied here. 700 MB space will be wasted, right? Same way, yeah, Tomcat occupied 350 MB, for example. So remaining space will be wasted right here. Remaining 650 MB will be wasted, right? Yeah, same way here, Python occupied 400 MB. Remaining space will be wasted, right? $600 MB will be wasted, right? So here Ruby occupied 450 MB, for example. Remaining space will be wasted. In 1990s and early 2000, project teams used to design like this. For each application, they used to configure one server, right? So 550 MB, right? So here, yeah, so Java occupied 300 MB, remaining space 700 MB space will be wasted. Yeah, same way Tomcat. So same way Python, same way Ruby also. So yeah, here server utilization is very less. Server utilization is very less, and in 1990s and early 2000, hardware costing, too much costing, right? Server hardware costing, even a laptop, even desktop also. In 1990s and early 2000, desktop costing 1.5 lakh, 2 lakhs, like that we used to spend, right? So server costing, too much costing. By the time, hardware costing, too much costing, right? So here, utilization is very less and costing is higher. That is why this model is failed model. This is the failed model. Okay. Slowly, after 2000, yeah, after 2000, slowly, after 2000, in the second phase of implementation, what happened? Second phase of implementation, the project teams used to take one high-end server. Project teams used to take one high-end server, high-capacity server. So in that, they used to deploy all the packages like Java, Tomcat, Python, and also Ruby. So the project teams used to take one high-end server. They used to configure all the applications on the same server. Okay. So here, Java user may access Java application. Python user may access Python application. Tomcat user may access Tomcat application. Ruby user may access Ruby application. So they can access their respective applications, right? So sometimes what will happen? Yeah. So Java user may access Tomcat application also. There may be chances to access. Tomcat user may access Python application also. There may be chances. So Python user may access Ruby application also. There may be chances to access other applications. So four people are accessing same server, right? They may access other applications also. There may be chances to access other applications, right? Because four people are accessing same server. This is one drawback, and this is one drawback. So in case the service crash, what will happen? In case the service crash, what will happen? All the applications will be gone. All the applications will be gone. This is one more drawback. This is one more drawback. So that is why this is also failed concept. This model also failed, right? failed concept. This is also failed. So this is also failed, right? Yeah, these two models are failed models. That is why, yeah, slowly. Yeah. So project teams, they started using virtual missions, virtualization, virtual servers. So what is virtualization? What is virtual server, anyone? What is virtualization? So what is virtual servers? What is virtual server? What is virtualization? Anyone having idea? Yeah. So in virtualization, we take one physical server, we take one physical server. So this can be, we can say base, the server we can say base operating system, base OS, right? So this is high capacity server, high end server. So here RAM 48 GB, CPU 32 core, storage 20 TB. So like that we can take one high capacity server, high end server, right? So on top of this, we deploy virtual software, which is, we can say, so either VMware, VMware or hypervisor, Hyper-V or Citrix. So these are all virtual softwares, actually. These are all virtual softwares. We can deploy the virtual software. So this will allow you to, once we deploy the, excuse me, yeah. So once we deploy the virtual software, this virtual software allows you to create virtual servers. So these are the, we can say virtual servers, or else we can say like this, look at here. So here, I just want to show you the 25 servers here. So as per the project team requirement, we can get the virtual servers. So as per the physical server capacity, we can get the virtual servers. So these are the virtual servers. Yeah, 5 into 5, 25 servers. 5 into 5, 25 servers. Here we can deploy the different operating environments, whatever we require, right? Here I want to deploy Ubuntu. Here I deploy RHCL, Red Hat Enterprise Linux. Here I deploy CentOS, CentOS Linux Flavor. Here I deploy Windows 2025 Data Center Edition. Here I deploy SUSE Linux, right? So like this, whatever the operating systems you want to configure, you can configure as per the project team requirement, right? Yeah, so still we are using virtual servers, but here we have some drawbacks. So what are the drawbacks we have? Right? So when you want to deploy operating system, when you want to install operating system, we use ISO image. ISO image. What is ISO? International Standardization Organization. So which is a full-blown operating system. Full-blown operating system, right? Yeah, this ISO image size would be 8 GB to 8 GB to 18 GB, 8 GB to 18 GB, right? So let us say on an average 10 GB each server, 10 GB, 10 into we have 25 servers are available. So equal to 250 GB we need to spend for only operating system, right? So 250 GB we need to spend for only operating system. So on top of that, we need to deploy applications, plugins, patches, right? So whatever we require. So we need to deploy, right? All the applications, patches, plugins. Yeah, it takes more space, right? Takes more space. Fine. And also, look at here. When you want to restart Jenkins, sorry, restart any server, not only Jenkins. So if you want to restart the virtual server, okay, it takes 4 to 8 minutes. When you want to restart virtual server or physical server, takes 4 to 8 minutes, right? So normally client will not accept the 4 to 8 minutes. They will not give downtime 4 to 8 minutes. So that is very normally clients what they will think normally. If the service, if I approve for the downtime, the service is not restarted properly, the service crash, applications will be gone, database will be gone, right? So that is why they will not accept for 4 to 8 minutes downtime. So if you down the server for 8 minutes, for example, so business will be impacted, right? For example, Flipkart server. So Flipkart server normally 24 by 7 we run the Flipkart server, right? If the server is down for 8 minutes, what will happen? And client business will be impacted. That is why client they will not accept for the downtime, right? So here 24 by 7, 24 by 7 server should be up and running fine. They ask you to run 24 by 7, right? Yeah. And also here deployment time and a downtime is high. So deployment time. So when you want to deploy applications, that takes some time. When you want to down the server, that takes some time. Deployment time, downtime is higher, right? So moreover, license cost is high. License cost is high. These are all drawbacks. So these are all drawbacks, right? So virtual servers are physical servers. We need to follow all the steps, right? So first of all, ISO image we need to use. ISO image is a full-blowing operating system. So ISO image size minimum 8 GB to 18 GB, right? So on an average, we can take 10 GB for each server. 10 into 25 equal to 250 GB. We need to spend for only operating system. So on top of that, we need to deploy the applications, configurations, patches, plugins, right? And restart time 4 to 8 minutes. When you want to restart, it takes 4 to 8 minutes. And also deployment time, downtime is very higher. License cost is higher, right? So these are all drawbacks. These are all drawbacks, right? Yeah. So that is why every project in every organization, they're migrating their applications to next phase of implementation. So this is third phase only. Third phase. So in the next phase of implementation, which is fourth phase, which is Docker architecture. Docker Docker architecture. So yeah, fourth phase of implementation is Docker architecture. Fine. Yeah. So here in the Docker architecture, so same as virtualization, what we will do, we can take one server which can be cloud server. We can take a server which is we can say Docker server, Docker server. So this is a AWS EC2 instance. So terminology is very, very important. So terminology is very, very important. So EC2 instance is a server. EC2 instance is a server, right? Yeah. So this is a Docker server, which is a AWS server. Okay. So on top of this, what we will do, we can deploy Docker image, Docker image. Yeah, once we deploy Docker image on this Docker server, so this will allow you to create Docker containers. This will allow you to create Docker containers. These are the Docker containers, right? So here, when we create a Docker container, okay, what will happen? In this Docker containers, only lib and bin files will be configured. So on this Docker containers, only lib and bin files will be created. So here, look at here. Yeah, so different operating environments we can configure here. For example, here, Ubuntu, RHCL, Red Hat Enterprise Linux, CentOS, here Windows 2025, Data Center Edition. So like this, whatever the operating systems you want to configure, you can configure, right? So when we are using Docker containers, right, we don't require any ISO image. We don't need to configure any ISO image. Here we can, yeah, we can use the Docker image. So this Docker image size would be 200 MB only. This Docker image size would be 200 MB only, right? So here, very less size, right? Compare with virtual servers. So 200 MB, not even 1 GB, right? 200 MB, right? Very lightweight. So when you want to restart container, it takes 15 seconds only. This will take 15 seconds only whenever you want to restart container, right? And also deployment time and the downtime is high. So deployment time and downtime is very less Sunday is very less compared with virtualization. And also no licensing and here no license. So they will take care. Vendor will take care. Okay. Yeah. So these are all okay. So license we can say minimum license we can say minimum costing. Okay. Fine. So these are all the advantages of Docker architecture. So compare with virtualization. So these are the advanced features we have in the Docker containers. Like Docker image size would be 200 MB. So very faster, quickly we can configure So restart time 15 seconds only. So if the developer is working on the container, they will not understand whether it is restarted or not, right? Because so quickly the container will be restarted, and also deployment time, downtime. So when you want to deploy any applications quickly, it will allow you to deploy. And when you want to down means restart time, maintenance time is very less. So these are all advantages of Docker containers, right? So client always look for the cost saving, time saving. Here, minimum license cost, right? Yeah, time will be saved quickly, very faster, right? So that is why currently every organization, every project team, they are migrating their applications to Docker architecture, Docker containers, right? Because containers are lightweight, standalone, executable program, very faster, clear and everyone. So currently, every organization, they are migrating their applications to Docker architecture, Docker containers, because, yeah, time saving, cost saving. Clear and everyone. Any questions so far, anyone? Yeah. Now, let's try to understand something like, yeah, Docker, Docker implemented in 2013. Docker implemented in 2013. Docker released in 2013, right? So in this, yeah, after 1 year, Kubernetes released in 2014. So difference between Docker and Kubernetes is very, very important. And every interview we get this question. Every interviewer asking this question, right? So difference between Kubernetes and Docker, right? So Docker released in 2013, Kubernetes released in 2014. So what are the difference, major difference between these two important tools, right? Yeah. So Docker is yeah, Kubernetes is advanced Docker. Docker is advanced one. Kubernetes is advanced Docker. What are the differences here? So few differences I will explain here. Yeah. So Docker supports, second difference here is Docker supports 95,000 containers. Whereas Kubernetes supports 3 lakh containers. Kubernetes supports 3 lakh containers. Docker supports 95,000 containers. Kubernetes supports 3 lakh containers. Right? Yeah. And also, yeah, sorry for the break again. So some power distractions. Okay. Yeah. So creating and managing clusters is very easier. Right. So here, very easier in Kubernetes, right? So creating and managing cluster is very simple. Very by using single command, we can create the cluster in Kubernetes, right? So these are all advantages of these are all differences, right? So interviewer ask you, so what are the major differences here in the Kubernetes between Kubernetes and Docker, right? So first difference is container support. Container support. 95,000 containers are supported by 95,000 containers supported by Docker. So 3 lakh containers supported by Kubernetes, right? So cluster is, yeah, in Docker, creating and managing cluster is very difficult. In Kubernetes, by using single command, we can create and configure the cluster, right? And also year released, right? These three are very, very important differences, right? So currently, every organization, every project team, they're using Docker because of time saving, cost saving. Okay. Yeah. Any questions, Sandy? So far, anyone having any questions here? Anyone having any questions here? So far, any questions you can ask me.
Yeah,
Clear, right, everyone?
what is cluster?
Yeah. So very good question. Yeah. That concept will be covered in our course. Let me explain. Cluster. What is cluster? Yeah, this is a very, very important question, Andy. So in tomorrow's session, this will be covered. Let me explain right away. Okay. So cluster is a group of servers. Cluster is a group of servers, right? So cluster is nothing but a group of devices, like a group of people also we can say cluster. Okay. So what are the advantages of cluster? What are the advantages of cluster? Advantage of cluster. So cluster advantage here is load balancing, load balancing, and also fault tolerance. Load balancing and fault tolerance. So cluster is nothing but a group of servers. Advantage of cluster is load balancing and fault tolerance. Load balancing. What is load balancing? For example, we have 10 servers which are in the cluster, the group. So the 10 servers equally, yeah, load will be shared within the cluster. The 10 servers are having, for example, two applications running on the 10 servers, right? So that load will be equally shared onto the respective servers. For example, in the team, 10 members, we are working with the team. We are working with the team, 10 members. So everyone getting daily 10 requests, 10 into 10 members, 100 requests. One fine day, we received 200 requests. The request will be shared to the team within the team equally, right? So each one get the 20 request. That is nothing but load balancing. Fault tolerance. What is fault tolerance? For example, 10 servers are working fine within the cluster, in which two servers are crash, two servers are down. So project will not be stopped. Application will not be down. Other servers will take care of the application. So same way, 10 people are working with the project, in which three people left from the organization. Three people resigned. Project will not be stopped, right? Project will not be stopped, right? Yeah. So cluster is nothing but group of servers, load balancing, and fault tolerance. These two are advantages of cluster. Any other questions, Andy? Anyone? Any other questions, anyone? Right. Yeah. So here, next one, let's move on. So this is the server architecture. Okay. So servers can connect to the storages, network, right? To share the resources, to share the databases, right? So each server can have, yeah, communication connection between servers and storages because to share the information, to share the resources, right? Fine. So next one, what is operating system? What is operating system? Let's try to understand. So what is operating system and anyone? Anyone having idea? Operating system is a, yeah. For example, operating system is nothing but our interface only. Okay. So computer hardware always understand binary language. Computer hardware always understand binary language. So binary language is nothing but zeros and ones. 000, 001, 100, 111, like this, right? But a human will not understand binary language. Users will not understand binary language. So that is why we require one translator, which is operating system. Operating system is nothing but it is a interface between user and the computer hardware. So look at here. This is the definition. Operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication. Understanding it, everyone. Operating system is an interface between user and the computer hardware, right? So it will translate the human language to hardware, hardware to human language, vice versa, right? For the effective communication. Look at it. So, yeah, hardware and end user. Between we have operating system, right? It will translate hardware to end user to hardware. Next one, types of operating systems. Look at here. Single user, single tasking operating system. In this type of operating system, only one user can log into the system. He can perform only one task at a time, which is nothing but single user, single tasking operating system. So for example, MS-DOS, look at here, Microsoft Data Operating System, right? So in this operating system, only one user can log into the system. He can perform only one task at a time, right? So next one is single user multitasking operating system. In this type of operating system, only one user can log into the system, right? He can perform multiple tasks at a time. Single user multitasking. So for example, Windows. In Windows, single user can perform multiple tasks. For example, while working on any deployment activity or any other activity, we can run background audios, right? We can run the background audios, right? Yeah, one user can perform multiple tasks in the Windows environment. So third one here is multi-user multitasking operating system. Multiple users, yeah, they can log into the system. They can perform multiple tasks at a time, which is nothing but multi-user multitasking operating system. So for example, Linux. Every project in every organization they're using Linux currently, right? Because multi-user multitasking, multiple users they can log into the system. They can perform multiple tasks at a time, which is nothing but multi-user multitasking operating system. Clear and everyone? Clear and everyone? Any questions so far, anyone? So tomorrow we are going to start networks, computer networks. Okay. So far, any questions, Andy? You can ask me if you have any questions. So tomorrow networking concepts discuss. After that, we'll jump into AWS. We'll start AWS. Fine. Yeah. So if you are interested, you can register, Andy. So link may be changed very soon. Okay. So you can register as soon as possible. Fine. Yeah. We can stop here. Thank you all.